Hello and welcome back to Yeyu Lab. Today we're going to take a look at how to build a Gemini-powered Chrome extension with live voice chat that can support your web browsing or web app usage in real time. The Google's Gemini Live API has opened up some great opportunities for creating truly interactive AI assistants. We've seen demos in Google AI Studio and even built web apps that let a user to share their screen and talk to an AI, which is a powerful setup for tutoring or on-the-job help. The key part of it is the Gemini Live API, which lets us stream both voice, audio, and screen capture like image or video in real time and get a natural spoken response from the model. But there's a big challenge when using a normal website for this. These web sharing chat app use the browser's built-in screen sharing tools, which creates a potential problem. Let's see what I'm doing. Screen sharing. Find a tab. Hey, what do you see on this page?
On this page, I see the Live API Capabilities Guide for Gemini AI. It looks like it's a comprehensive guide covering configurations available with the Live API, and it's currently in preview. Is there something specific about the page you would like to know?
Okay, these are the transcription of our last conversation with Gemini model, but you cannot see this transcript text in your targeting website. That means when you do the actual operation on your target website, you cannot see any settings or any informations, transcript text, dashboards from your assistant website. But when you back to your assistant website, you cannot operate on your target website, right? You can only see a non-interactive preview window shows what you are sharing with the model and can see the transcript text and can do settings and configurations for this conversation. There's a big problem when you want to provide unique or important functions for your user for using your assistant web app. And also there's another problem. It's very hard to control your user. Where is your web assistant tool can be used? For example, limiting the assistant to only work on some technical documentation, which provide users the technical conversation with your design assistant is very hard because they can switch to any website they want. They can switch to the news, they can switch to the entertainment website and talk to your assistant if you are not carefully controlled. That will be a waste of your tokens and also be out of your control. So what I'm thinking is if there's a solution that can inject itself into the page that you want to share with the model, running alongside with the user's active website. This lets us show our assistants the interface without making the user leaving their current work. So a Google Chrome extension is perfect tool for this job. So today we will walk you through building this kind of extension from the scratch. By the end of this video, you will understand how to build a side panel interface, manage live voice communication using a direct WebSocket connection for the Gemini Live API, and capture user's screen to give a full context to the AI. This guide will give you the complete technical plan so you can build this powerful assistant for yourself or use it as a starting point for a bigger product. Okay, so let's quickly see how this Chrome extension works by this demo. So let's make sure that Yeyu Lab chat extension has been loaded and working properly. And then you will find there is a button on the right side showing open Yeyu Lab chat. When you click, here is the side panel that triggered by this button, which is actually our extension. Let's click the start. Hey, what do you see on this page?
Okay, I see a web page titled Live API Capabilities Guide on the Google AI for Developers website. It looks like a comprehensive guide covering capabilities and configurations available with the Live API. There's also a table of contents to navigate different sections, like establishing a connection, interaction modalities, sending and receiving text, sending and receiving audio, and more. Is there anything specific you'd like me to focus on?
So what is this voice activity detection means? I don't know its background. So please give me the ideas from this content they provided.
Okay. From what's on the screen, voice activity detection, or VAD, allows the model to recognize when a person is speaking. It's useful for natural conversations, as it allows a user to interrupt the model at any time. Does that clarify it for you?
So what is this code for?
The code you're pointing at appears to be a Python example for sending real-time audio input to the model using the Live API. It seems to be setting up a session, reading audio bytes from a file named sample.pcm, and then sending that audio data to the model. Does that help clarify what the code is doing?
Okay, we just stop this call to the Gemini Live API, and you will see it's very smooth and interactive app that can be used for any kind of web browsing assistant. And even you don't have to start and stop again, you just smoothly move to other window that is also available like this. Alright, so before we get into the main project, let's cover the absolute basics of a Chrome extension. If you've never built one, this will get you started in 5 minutes. An extension is just a group of files, including HTML, CSS, and the JavaScript put together. The most important file is the manifest.json file, which tells the Chrome what the extension is and what permissions it needs and where to find its other files. So here we just kick things off by creating the simplest possible extension, which will just show a pop-up text by your clicking. So first we should create a folder, put all the source file into this folder. Next, inside that folder, you should make sure you have manifest.json file. So it just has the manifest version, a name, app version, and description of this extension, and including the action that points to pop-up HTML as a default pop-up mechanism and an icon for the default icon. So let's look at the pop-up HTML file. It's still a very, very simple HTML, which including only a headline, say hello world in the body, and that's it. That's the simplest extension. And how do we load this into Chrome? Let's see. It's also very simple. And that's it. So now how do we load this app into Chrome as an extension? It's also very simple. So first open the Chrome, type the URL Chrome extensions to go to the extension configuration page. Next, in the top right corner, you need to turn on the developer mode. Once you do that, you will see a load unpacked button showing in the left hand side. Click that button and select the folder you just created with your source code. Here is the Chrome simple. Let's select. And then you will see a new Chrome extension has been listed in this page. Just like that, you have a complete simple Chrome extension. Let's try it. Open any website, click this extension button, and you will see Hello World extension that's in the list, and you click that. Here you will see a Hello World pop-up text show. That's the function that we have designed. That is a very entry-level development guide for Chrome extension. So here's how it works in a typical interaction. First, the user clicked the floating chat button on a web page that content.js file sending a message to the background script in background.js, which works as a hub to send a message to the side panel UI to open the UI. Then when the user clicks the start button in the side panel, it will ask the background again for microphone permission and screenshot permission by using the Chrome extension API to ask for the permission from the permission helper that defining the permission.js and HTML file, and also capture the tab screen by using the Chrome extension API. From there, the side panel captures the microphone audio and send it to the special audio worklet for processing. That worklet resamples the audio and send it back. At that point, the side panel sends the processed audio and screen capture over a WebSocket connection to the Gemini Live API. Gemini then streams back the transcript and the spoken audio response, which our side panel shows and plays. Now let's talk about the message protocol. So why are we talking about the messaging protocol is because one of our main challenges with Chrome extension is their security policy. This often stops outside toolkits from working. So that means the existing JavaScript SDK from Google Gemini will not be working for extension. To get around this, we will build the Gemini Live connection ourselves using a raw and native WebSocket connection by understand fully about the Gemini Live API. So first is the connection. We open a WebSocket to Gemini Live endpoint, passing the API key in the URL. The endpoint of the WebSocket is a little bit long, so make sure now they have using the V1 beta. Next, once the WebSocket is open, we have to send a configuration message called setup. This tells Gemini what model to use, that we expect an audio response, and a voice configuration to choose the voice that we prefer, and system interaction that you can provide your own custom interaction to the model to how to behave and how to respond. And two of the most important settings is the input audio transcription and output audio transcription that should be enabled by provide empty to these keys. That will enable both transcription during the audio processing. After the setup, all our other imports are sent into the real-time import message. For audio, we base64 encode the audio trunk and send it with audio PCM MIME type and a rate of 16K. And for an image sending, and also use base64 encoded image data with the MIME type image PNG in the media trunks to send. And for the receiving output works like this. The Gemini sends back the JSON message. Our onMessage handler, which will be introduced in the code, will read this. It looks for the input transcription field to read about the text of transcript from the human input, which is our speech just now, and also the output transcription, which includes the text of the transcript from the model's output speech, and the model turn for actual audio data from the AI, which is also the base64 encoded MP3 audio data that we can use to play on the front end. And looking for the turn complete value to make sure you have collected all the audio trunks in a complete response. Now let's jump into the code. Again, the full code of this project can be found from my GitHub repository, and I share the link in the description below. So feel free to download and build your own project based on that. Okay, let's see how these different files works together. So first, again, let's see the manifest JSON. This is the main setup file I have mentioned before. I want you to pay attention to a few things here. Under the permission, we are asking for the side panel, tab capture, and the storage. So that is the key resource that we ask for this project. We also need the host permission for all URLs, so we can inject our content script into any web page that we want. And a very important part is the web accessible resource. This makes our other files like the permission HTML, permission JS, audio processor JS can be used in the web page. Next, let's see the background JS, which is the control center of this project. The most important part here is the Chrome runtime message add listener function when it receives a message with the action capture screenshot here that triggers by user's chat start. It will call the Chrome API to capture the visible tab and sends the results back. Then let's move to the content.js. This script is added to every web page. Actually, its main job is to create the floating button that you see in the front end. When that button is clicked, the handle activation function will be called to send a message to our background script to toggle the side panel. It also listens for the messages from the background script to inject a hidden iframe for handling permission, which is defined in the inject microphone permission iframe to help you smoothly get permission of using user's microphone. Now let's see the side panel JS. This is the script that works as a heart of the application. It has a class called Gemini Live Assistant that holds all the logic for communicating with the Gemini of the actual AI functionality. It has a start live chat function to be called when the user starts a chat, which coordinates everything inside this live chat processing. A key part is the inside of the start recording function. Here we create a new audio worklet node and point to our audio processor JS file. Here the audio worklet node put on message handler for this node is what takes the processed audio base 64 encoded it and sends it to the Gemini session by using our defined send real-time input function with the data that we defined in our message protocol. And let's quickly look at the audio processor JS file. This is the high performance audio worklet processor that runs in a separate thread. It process methods gets raw audio from the microphone and put it into a buffer. When the buffer is full, send the resampled buffer function performs a simple linear interpolation to resample the audio down to the 16K hertz that Gemini needs. Then it converts it to an int16 array and posts it back to the side panel. And also we have the permission JS and permission HTML files. This implements a very common function when your application on the website need to use the user's microphone. So the solution is to have the content script inject a hidden iframe that loads our permission HTML. That page then runs permission JS injected in the user's active HTML, which can ask for permission. And finally, we have the Gemini Live JS, which is a clean wrapper around the WebSocket API, which is actually the implementation of this message protocol. It just provides simple methods like connect, send the real-time input to our side panel.js to use, and hiding the complex details. Now the code is ready. Let's do it again to import our project code into a workable extension. So the process is still the same. Make sure you have opened the developer mode and click the load unpack it button. Choose the source file. Choose the folder that's including all the source file. Select, and then you will see EAU Lab chat Chrome extension list in the extension page. And move to any website you are actively browsing. Refresh it. And then you will see the small button shows on the right side. And we clicked to toggle our extension. Okay, that's it. But you need to know this is only available for your personal use. So if you want to release to the public, you should make sure you have the official permission for release an extension and pay a little money to the Google Web Store. Have the permission to release your extension app to the Chrome Web Store. Follow the official steps to make that happen. And that's all for today. I hope you find that helpful. Again, the source code for this entire project is linked down in the description below. So feel free to play around with this code and make it your own. If you have any questions, drop them in the comments below and I will do my best to answer them. Thanks for your watching and I will see you in the next video.